Now we already spoke about atoms and atomic structure, and we said that atoms are the building blocks of our world, of mass and matter. Now there are many different types of atoms that exist, and something called the periodic table represents all these atoms in a certain way. Now over 100 different types of atoms exist, and each atom is called an element. Now each element found on the periodic table of elements is represented in the following way, where this X is the symbol of our atom. Now in this case it's just X, it's a hypothetical symbol. But for example, carbon has the letter C and oxygen has the letter O. Now this A and this C are usually numbers, but in this case we're going to use letters. The A is the atomic mass and the Z is the atomic number of our element. Now the atomic mass is the mass of that element. It's the number of protons and the number of neutrons. Now note that electrons are not counted in our atomic mass because their mass is much smaller than that of the proton or the neutron. Now the atomic number is the number of protons of our element. Now that number, the atomic number, is the identity number of that element. It's used to identify our element. It's the fingerprint of that element. And that's because any element can have different number of electrons or neutrons, but it will always have the same number of protons. And that's why you could use the atomic number to identify our X, our element. The second that the number of protons changes, that means our element also changes. Now let's go into something called isotopes of elements. Now two or more atoms that contain the same number of protons, meaning they're the same element, but have different number of neutrons, are called isotopes of that same atom. Let's look at a very common example of carbon. Now carbon has 3 isotopes. Now in each case, because this is a carbon atom, it must have the same number of Z. The atomic number must be the same. In other words, all 3 have 6 protons. But notice carbon 12 has 6 neutrons, carbon 13 has 7 neutrons, and carbon 14 has 8 neutrons, thereby giving the atomic mass 6 plus 6, 12, 6 plus 7, 13, and 6 plus 8 is 14. So that makes sense because to get the atomic mass, to get the A, you have to add up the protons and neutrons. Now there is a unit that scientists created to deal with very, very small amounts of atoms. Now the AMU, or atomic mass unit, is the unit of mass used for elements and compounds. Now by definition, we define that one atom, a single atom of carbon 12, is composed of 12 AMU, and everything else is relative to this amount. For example, an H atom is 1 AMU, and it's relative to this. In other words, this is 12 times as heavier in terms of AMU than an H atom, a single H atom. Now, note that this is 1 atom of carbon. That's a very tiny amount. It's much, much smaller than grams or kilograms or pounds or anything else. This is a very, very small amount. So AMU is not a very large measurement.